Hi everyone, I'm Jonathan Alcala, and this is my option pricing and risk explorer project. In this walkthrough, I'll show you the code files, explain what each module does, and give you a sense of how everything fits together. So right now I have my GitHub repo pulled up, but I will be going to my actual code and giving you guys a run through there. So as you can see on the left, here is my file structure. So at the top level, we have our source code, and it's now named Option Greeks dashboard. All right, and then we have the test file, which is just a unit test for helper functions and data loading. You can see here the two Python files, and then I have the requirements.txt files for dependency management and installment configuration. So the setup, that's what the setup.py file is for as well. And then just the README file for documentation. So first let's start from the top. Let's look at our source code. All right. So the first thing I'm gonna open is split up into data, Greeks, pricing, UI, and utilities. So first let's go into the data. Let's go at our loader.py. So this module's job is simple. It fetches historical closing prices from Yahoo Finance. So very simple. We import from Pandas and Y Finance, and then the fetch historical prices calls the Yahoo Finance.ticker.history, and it keeps only the close column and returns a neat data frame with columns date and close. This function feeds the historical tab of our app. And then let's open up the, give me one second, I'm gonna open up the compute.py file. So here we wrap quantlib's engines to compute option prices and Greeks. So here is the make European option function, which configures a European payoff to flat yield and volume term structures and instantiates a Black-Scholes-Merton process. We can see here. And then we attach the analytical European engine, so we call .npv for price. Then we expose 5 functions: Black-Scholes price, delta, gamma, theta, vega, and rho, each of which reuses that engine to compute respective quantity. Note that theta is divided by 365 to get per day decay. And then now we go into the pricing module, and it's called blackshoals.py. Okay, so in addition to the analytics price, we also support a binomial tree engine. Black-Scholes price simply calls into make European option from earlier, and in the Black-Scholes price binomial method, we'll first rebuild the BSM process, but with zero dividend yield and a flat volume. Maps a tree string with CRR, JR, etc. to quantlib C++ class, and instantiates a binomial vanilla engine, which with a chosen tree and a number of steps. And then it returns the .npv. This gives users a discrete approximation and lets them compare analytical versus binomial pricing. All right, and then if we go into the helper simulations, see? So right here, to illustrate stochastic dynamics, we provide 3 simulators. The GVM to the geometric Brownian motion, classic long normal processes, and then the Ornstein-Uhlenbeck, which is mean reverting process. And then we have the variance gamma, which is the pure jump process from heavy tailed returns. Each function, simulate GBM, simulate OU, simulate VG, returns a pandas.data frame where each column is one path and the index is time. These power the processes tab in our app. All right, and then if we go to plotting utilities, here, scroll up. Rather than clutter the UI code, we factored out complex plotly figures here. So the plot payoff shows an options payoff at expiration versus underlying price with a horizontal line for the current model price. The price surface builds a 3D surface of price versus strike and maturity using go.surface. The implied vol smile method loops over strikes, solves the implied volume that matches a given market price and plots the familiar smile. And then we have the Greek surface. This is a 3D surface for delta, theta, gamma over S and T grid. And then we have animate pass, which uses Plotly's animation frame to animate any time series data of pass, which we didn't end up using because I had trouble integrating it. So we just have the normal stat unanimated plot. So keeping these helpers separates keeps our app.py clean, which we will later go into. All right, and then now we can go into the UI, which is in this app.py file. So finally, here's the heart of the dashboard. So first is the page setup. It's a dark theme with a custom favicon wide layout. So then we have the sidebar and an about and learning objective expander with bullet points, input controls, spot price. Some of the input controls we have are spot price, strike, maturity, risk-free rate, volatility, option type, price engine, and historical ticker / period. Each control has a help equals tooltip and a caption underneath for clarity. And then we can move into, here's where the input parameters are, with each of them having a help message. So if we scroll down, we have, these are going to be our tabs. So we have metrics, which is the real-time Black-Scholes price in Greeks with the bar chart summary and Greek definitions expander. And then we have the sensitivity line chart of each Greek versus volatility sweep. And then we have surface and smile, which is a 3D price surface and an implied volatility smile. And then we have Greek surfaces, 3D surfaces for delta, theta, and gamma. And then we have payoff diagram with model price. And then we have historical, pulls and plots close prices from using that fetch historical prices method from earlier. And then we have processes, which is just static plots of GBM, OU, VG with a descriptive legend. Each section uses our helper functions to keep the code readable. So here is, the metrics, and then we scroll down, we have our sensitivity tab, and each of these is split into kind of like each tab. So this one's showing just what the header is, what we're doing. And then this is a surface smile, how we calculate it, we use a Plotly chart. And then here's a Greek surfaces, this is the code for it, which we use, things like, if I could scroll up. So here we import all the packages we need, as well as, for my module, option Greeks dashboard, and then this is how we import everything that we need. Okay, and then we have the test. I wrote a few unit tests to validate our helper and loader modules. I've given more time, I would have done more unit testing with the other modules that we built. So, and that's the full code walkthrough. The README covers the installation, if I can pull it up here. So it covers the installation, the features, the input parameters, screenshots, the roadmap contribution guidelines. And yeah, feel free to check out the code on GitHub, try yourself. And here, I'll just pull it up before I finish this so you can see how it looks like on my GitHub repo. So this is how the README file looks like. You can see there's how to the features, some screenshots, the input parameters, the installation, the repo structure, my references, the roadmap, and how to contribute. So thank you, and I hope everybody has a good day.